So let's look at the proof of this theorem. The statement is, if two lines intersect each other, then the vertically opposite angles are equal. So to think of anything, especially in geometry, we need diagrams. So that the diagram looks something like this. So we have AB and we have MN. So these are two straight lines intersecting at O, right? So let's describe it off. Consider lines AB and MN intersecting at O. So we have to prove. So let's think about what we need to prove. M is equal to N. We need to prove that M is equal to N. If not, A is equal to B. We'll call this as something else. We already used M. What else to call this as? AB is okay. A, B, C, D, E, F, G and H, I guess. Okay. So we need to prove that A is equal to B. If not, we need to prove G is equal to H also. So how do we go about now? What to do? So what is that basically we have to do over here? These two angles, we need to prove that they are equal, or these two angles, actually both. See, this entire theorem is based on the fact that AB over here and MN are straight lines. So with this fact, how can we relate A, G, B, H? How can we relate all of this? We know this. Because they are straight line, G and A adds up to 180 degree. A and H 180 degree, H and B 180 degree, G and B 180 degree. So now with this, can we do something? We can actually. Let's first write them off. So if I relate A and G and A and H, can I relate G and H? Because we need to get them to be equal. So let's do that first. So angle G plus angle A is equal to 180 degree. Reason? Linear pair. Right? So if I transpose, if I subtract with G both the sides or A both the sides. So this and this will get cancelled. So G is equal to 180 degree minus A. This is my equation 1. Then, okay, so I got an expression for G. Somehow if I get the same expression for H, my answer is done. And we can get it. It's quite simple. It's the same way. H plus A is equal to 180 degree. Subtract A again. So we have H is equal to 180 minus A. This is our equation 2. And here you need not write linear pair again because we already told over here. So not an issue. So from 1 and 2, what can you tell? From 1 and 2, we can clearly tell G is equal to H. Okay, clearly you can see that the RHS is equal, so the LHS has to be equal. This is again your axiom. So G is equal to H, and we have one of the proving things to be that we have proved, and we can tell. Similarly, we can prove A is equal to B, and hence proved. And this is your answer. Don't worry, you can write this, not an issue. Okay, so now pause and write it as neat as this or more than this.